In this video, we're going to talk about circles, which is a form of a section of a cone or a conic section. Before we get to the definition for a circle, I thought it might be good just to remind you about the distance formula, because the distance formula is a very big part of the equation of a circle. So the distance formula really is a way for us to give the distance between any 2 points in the plane. I'm just going to choose 2 points kind of at random here. We're going to label them. This point will be x1, y1. And this point will be x2, y2. Okay, so I would like to find the distance between them. We'll call that d for distance. And it's definitely related to the distance between these 2 points horizontally and vertically. So it would be good to kind of drop a perpendicular here to the x-axis. And then also kind of connect this together to make a triangle, a right triangle. Right, so when I look at this side, this actually has x value x1 and x2. To get the length of this side, I could subtract these two, right? x2 minus x1. I could draw the same sort of dotted lines over towards the y-axis. I'm not going to do that because I think it would make my picture look a little messier, but I could use that same idea, right? This has a height of y2, this has a height of y1. So this distance, just the side of this triangle, would be y2 minus y1. The distance formula is actually built on the Pythagorean theorem. Maybe I should have listed that here. Can we do that at the bottom? I'm sure you know the Pythagorean theorem quite well, but I'll list it down here anyway, and I'll spell it wrong. Okay, we'll go with that. That says Pythagorean. Okay, and that says that a squared plus b squared equals c squared. This only works for a right triangle where c is the hypotenuse or the side opposite of the 90-degree angle. Okay, so now let's use this in conjunction with the triangle we just drew. We have x2 minus x1 squared, that's acting like side length A, plus y2 minus y1 squared, that's acting like side B, and then the hypotenuse is the distance we are trying to find, d squared. Okay, but I don't want to have d squared, I'd rather have the distance, so I'm going to take the square root of both sides. So I'll have the square root x2 minus x1 squared plus y2 minus y1 squared. If I take the square root of d squared, I just get d. Okay, so this distance from one point to the other is calculated by a formula that looks like this. The equation for a circle looks a whole lot like this. So that's not a coincidence, right? If we were to take this and expand it into the equation of the circle, you could think of one of these points, let's say x1, y1, as the center, and then allow this point to rotate all the way around the center, keeping that distance d consistent. That's really the definition. So now let's go back to the definition. So the circle is the set of points in a plane lying a fixed distance from a fixed point. And that fixed distance is the radius, and the fixed point is the center. So here's the equation with circle with the center being h comma k. Notice how this and this compare. The radius being the distance from the center to the outside of the circle. Okay, if the center happens to be centered at the origin or 0, 0, then because h is 0, x minus 0 is just x, and then we square it. Same for y minus k, just be y squared. Okay, this is part of the chapter on conic sections, which means each of these shapes, two-dimensional shapes, can be achieved from a three-dimensional cone. So here's a cone. If we were to slice it horizontally, the base of this cone is a circle, so we would, no matter where we sliced it, we would also get a circle. Now this is drawn in perspective, so it doesn't look like a circle, but if we were to slice it and take it out, right, it would then look like a circle. Okay, so I thought we would start kind of simple and graph this circle. Here's an equation of a circle. This, by the way, is called the standard form for the equation of the circle. Actually, let me pull this down so you can compare it with what we have up here. Right, so each of these pieces play a part. So let's take a second and try to identify the center and the radius. So the center is h comma k. If you compare these two, what would be the value for h? So the value for h would be 1. Notice we have x minus a number, and here we have x minus a number. So the minus is sort of built into the formula. So even though we see a -1 here, we actually are taking the opposite for the value of h. Same thing is true for the k. You could think of this plus 2 as y minus -2, and the -2 would be the value for k. So the center this time would be 1 comma -2. And the radius, this is the radius squared. 16 is 4 squared. So the radius would be 4. Okay, so let's draw a picture of that. Here's our center. Sometimes I like to use a little X for the center since it's not actually part of the circle. It's just a reference point. And then we know the radius is 4. The easiest way to get some points on the outside of the circle is just to count north, south, east, and west. I did that backwards, east and west. Okay, so 1, 2, 3, 4 up. 1, 2, 3, 4 to the right. 1, 2, 3, 4 down. And 1, 2, 3, 4 to the left. All right, and then you're on your own from there. Just do your best to make it into looking like a circle. Okay, I think you may have some questions where you're asked about the domain and range for this circle. So remember that domain is the x values, and it's the set of all the x values that make up this circle from left to right. So the leftmost x value would be this point here, and it has a point at -3. Since we have a point there, we're going to use the bracket to show that -3 is included. We have points on the top and the bottom of the circle all the way over to this side. 1, 2, 3, 4, 5. Okay, the range is from bottom to top. This works the same way. It's all the y values used to make the graph of this circle. So the lowest point we have is at 1, 2, 3, 4, 5, 6, -6. And the highest point is at +2. Okay, just for fun, let's throw this question in. Is this a function? And the answer is no, because it does not pass the vertical line test, right? Some people like to call it the pencil test. So if I put my vertical line anywhere on this circle, it's definitely going to touch more than once. Right? I should say I could find at least one place where it would touch more than once. So it is not a function. Okay, sometimes you will be given an equation for a circle that is not in standard form, and you will be asked to put it into standard form. Let me put our standard form back up here. Okay, so to put it into standard form, you will need to do some completing the square. And you'll need to do that for both the x's and the y's, because we want to turn these two x terms into something that's a perfect square that looks like this. And we would like to turn these two y terms into something that's a perfect square. And then we're actually going to move the 16 over to the other side. And so everything that we end up having on the right is going to go together to make the radius squared. Okay, so the first step maybe would be to subtract this 16 over to the right-hand side. And then as I write the next line, I'm going to leave a space. So I'm going to have x squared plus 8x plus blank. And I'm going to have y squared minus 6y plus blank. And I have my negative 16 over here on the right. Anything I add on the left, I also have to add on the right. I like to draw in these little blanks because otherwise it's very easy to forget to add it to the right-hand side because we're paying so much attention to the left-hand side. Okay, so now you have to think back to completing the square, which I'm sure you've done in the past. So I would like to add a number here, so that when I factor these three x terms, I get two equal parentheses, which I can then write as a parentheses square. So there are two ways to think about this. One is to think about how it would have to factor. I like that method the best because then I don't have to remember any little trick, okay? But there is a shortcut, and I'll show you that in a second. So if I want to factor this into two equal parentheses, I need two equal numbers in the back that add to be 8. Because they're equal, there's only one choice, right? 8 and 1 is not going to work because they have to be equal, right? Likewise for any other combination. The only thing that's going to work, because I want these to be equal, is 4 and 4. It must be 4 plus 4 to make 8. Then you can think about just foiling this out, right? X squared, 4x plus 4x gave me 8x, and then 4 times 4 means I must be adding 16 here. And if I add 16 on this side, I also have to add 16 on this side. That's the basic idea of completing the square. The shortcut method is to take the number in front of x, divide it by 2, and square it. So if I took 8, I divide it by 2, that's going to give me 4. 4 squared is 16, and that's the number I needed to put here. Okay, you're still going to have to do some factoring, but if you're in a bind, this will work. Okay, so we did the x's. Now let's do the same thing for the y's. So the same idea, I would like to add a number so that I'm able to factor this into two equal parentheses and then write it as a square. I'm definitely going to have y and y. I need two equal numbers in the back that add to -6. Because they're equal, the only possibility is -3 and -3. And then -3 times -3 gives me 9. Anything I add to the left, I also have to add to the right. mostly because I don't want to change the equation, I'm just rewriting in a different form. So I have to keep it balanced. So this becomes y minus 3 squared. On the right-hand side, I'm going to add all these up. Negative 16 plus 16 will be 0, plus 9 is 9. So this is my equation in standard form. What would be the center and the radius? Remember that the negatives are built in, so you could think of this as x minus negative 4. So the center will be negative 4, comma 3. And this is the radius squared, so the radius must be 3. All right, one more question at the end here. This one is a bit of a long one. It says, find the standard equation of a circle with endpoints of a diameter being negative 3, negative 2, and 1, negative 4. Just to give you a good understanding of what this question is asking, let's go ahead and draw a picture. So there's one point here at negative 3, negative 2, and then 1, negative 4 is here. These are endpoints of a diameter, which means the diameter is a segment that goes from one end of the circle through the center to the other end of the circle. And so it's two radiuses together. So we could think about a picture that looks sort of like that. Somewhere in between these 2 points is going to be the center. Okay, so we will need to find the center and the radius so that we're able to build this standard equation. Okay, so the first step, you could do this a couple different ways. I'm going to find the center first. To find the center, I'm going to use the midpoint formula because the midpoint of that diameter is going to be the center. To find the midpoint, I take the average of my x values and the average of my y values. So let's do that. So we'll have negative 3 plus 1 over 2 and negative 2 plus negative 4 over 2. I'm going to use C for center. Negative 3 plus 1 would be negative 2, divided by 2 would be negative 1. Negative 2 plus negative 4 would be negative 6, divided by 2 would be negative 3. Okay, and we actually put that in the right place. I didn't mean to do that, but we did. Okay, so we have the center. This is going to give us the h and the k for our equation in just a minute. Then the other thing that we need is the radius. We could find the radius in two ways. We can either, now that we know the center, we could find the distance from the center to one of these points on the outside. Either one, because it's in the middle, even though I haven't drawn it super great. Both of these from here to here would be a radius, and from here to here would be a radius. Or I could use the two original points, find the distance between them, and then divide it by 2, since I have two radiuses. I am going to use the center and one of these other points. I'm going to use the second point, not for any good reason, just because I have to pick one. Okay, so let's see. We want to find the radius. And to do that, we're going to use the distance formula. We just derived this one, but let me jot it down one more time in case you need to see it. Okay, so I'm going to use the center and this other point. So the radius is going to be equal to the square root of -1 minus 1 squared. I'm doing x2 minus x1 plus -3 minus -4 squared. So this will be -2 squared plus, this becomes a plus, this will be 1 squared. So the radius will be, this is 4 plus 1. The radius will be the square root of 5. Okay, now we would like to put this into that standard form. So the we'll say equation of our circle will have x minus h, so x minus -1 squared plus y minus -3 squared is equal to the square root of 5 squared. Do one more line here, I'll squeeze it in at the end, at the bottom. So this two negatives, this is going to be x plus 1 squared plus y plus 3 squared. And if I square a square root, they cancel and I just get 5. All right, well, I hope that gives you a good idea of how to work with the formula for a circle and how to convert an equation into that standard form. So I hope you'll get some practice with this. Good luck. We'll see you in the next video.